Alright, let's move on here to example number 8. Find the maximum area of a rectangular region. So here we go. We've got this parking lot in the house here. And this community college wants to construct a rectangular parking lot on the land bordered on one side by a highway. Now it has 280 feet of fencing that will be used to fence off the other 3 sides. So we're only going to be fencing off these sides right here. So not the whole thing there. Kind of get rid of that. All right, so we're only fencing off those 3 sides. What should be the dimensions of the lot if it is enclosed to be in a maximum? Okay, so it kind of makes sense, right? I mean, you want to fit the maximum amount of cars in there, so you want to have the maximum area given that you only have 280 feet of fencing. And once you find the dimensions of the maximum area, and then what is the actual area then? Okay, and this is when the application of quadratics comes in, and I'm going to show you how that works here. So check this out. Well, we know that when we find any kind of area of a rectangle, we have to have the length and the width. Well, we're going to let the width be x. So that means my length then, which is the remaining, well, doesn't that have to be 280 minus 2x? Meaning I know that all 3 sides, if I add all 3 sides up, I have to get 280. So I take 280 and I subtract this width and that width, which leaves me just the rest of 280, which is why my length is 280 minus 2x. Okay, so that's going to be my length. So if I want to find the area of this, well, the area is just length times width. Well, that's easy, right? So that's x times 280 minus 2x. And you doing the distributive property, we'll get 280x minus 2x squared. Okay, so this is the area. This is the area of this rectangular parking lot. So check this out here. This is just what I want to show you real quick. If you graph this on a graphing calculator, it will look something like this. Okay. And what I want to show you is how does a quadratic relate to this area and the graph and all that. So again, what did we let x equal? What does the x represents right here? Well, the x represents the width, right? So that's what this is. So as the width goes along, look at what happens. If the width is 1 foot, 2, 3, 4, 5, it doesn't matter what the dimensions are. This is just for visual sake. Whatever the width is, this right here is going to give us is going to be giving us the area. Okay, so as you go along here, this is going to give us the area. So as this climbs along, it's going to get the area is going to get bigger, bigger, and bigger, and bigger, and bigger, and then it maximizes right here, and then the width gets smaller and smaller and smaller and smaller and smaller. And that makes sense because if you have a really skinny rectangle, then you can have a really small width but a long length, which means that the area won't be as big there. So that's what's going on right here. All right, so what I want to do is this then, okay, doesn't it make sense that we want to find the vertex? Because if you know what the vertex is, the vertex would give us the maximum area, right? I mean, that's pretty cool right there. So I'm going to take this quadratic and I'm going to find its vertex. Okay. So we have our function, and I'm going to label it f of x. So we have negative 2x squared plus 280x. All right, so let's find the vertex, and I'm going to use the vertex formula. X equals negative b all over 2a. So negative b 280 all over 2 times a, or negative 2. So that's negative 280 all over negative 4, and that gives us 70. So we know that the width has to be 70. We know that our width has to be 70 feet. Well, if we know that the width is 70 feet, well, can't we find what the length is? Well, yeah, right? Well, the length must be 280 minus 2 times 70, which is 280 minus 140, which is 140 then. So we have just found the dimensions of the maximum area. The dimensions are 70 feet by 140 feet. Okay? Now, what is the actual area then? And then you say, okay, well, what is the maximum area? Well, now then you just plug it into our area formula right here. So the area is x times 280 minus 2x. So again, x was our 70, so we'll have 70 times 280 minus 2 times 70. And doing all that on your calculator, you'll get 9,800 feet squared. So this is our maximum area, and this is the dimensions of our parking lot.